I bet you have seen this picture of Euler, but did you ever think why was his right eye squinted? And did you know that Euler turned completely blind by the age of 64? Euler was an extremely productive researcher. In the year 1775, he, on average, produced a new paper every week. A paper a week. We owe the discovery of Euler's talent to Johann Bernoulli, who was lecturing young Euler in the University of Basel. In 1726, he was invited to work at the newly formed St. Petersburg Academy, where the two Johann's sons, Nicholas II and Daniel, were already working. He would stay there up until 1741 and returned to St. Petersburg some years later. During this period, Euler made numerous contributions to number theory, calculus, and even music theory. When studying Goldbach's inelegant theorem, he has rediscovered and proved Fermat's little theorem. In calculus, he calculated these beautiful integrals, and they became, along with the zeta function, the most important non-elementary transcendental functions of the 18th century. And in 1735, he calculated a constant that now bears his name. It reflects a difference between harmonic series and a log function. But this result is my favorite. P is the set of prime numbers. And if you think hard about the right-hand side, you realize it gives Riemann's zeta function. And here's the magic. Plugging in 1 for S, we get harmonic series, which diverges. So the left side must have infinitely many factors, which shows that the set of prime numbers is infinite. I think this proof is so much better than Euclid's. Euler was able to combine mundane work for the Academy and his personal mathematical endeavors, and his work was recognized. Beginning in 1727, Euler won 12 annual Paris Academy of Sciences prize, and each prize was worth around 2,000 French livres, which was equivalent to almost 700 grams of gold. Euler was an extremely productive mathematician, but it was cartography that deteriorated his health. Making maps was a very laborious task in the 18th century, and it required astronomers to make precise measurements of the stars and planets, which would then be used to compute the position of something on Earth. One of the most common methods is called an intercept method. At a certain time of the day, you measure the angle that some star makes with the horizon. This allows you to calculate the height of the star above Earth. But there are many positions from where the star makes this angle with the horizon. Namely, all of these positions will form a circle on the sphere of our planet. So, if you know the angle and the distance, you still can't figure out your exact position. The only thing you know is that you're somewhere on this circle. In order to get your exact position, you need to measure a different star at that same time. So you get a second circle which only has 2 intersections with the first one. And it is usually quite obvious which of these 2 points to choose. But the devil is in the details. Calculating this intersection involves an impossible amount of trigonometry, which had to be computed by hand back in the days. So, this is what blinded Euler on one eye in 1738. His academy received an urgent task of computing hundreds of these positions to make a new map of Siberia. The old map was so bad that even north and south were reversed. Euler's fellow academicians claimed that it will take them several months to complete the project, but then, only 3 days later, Euler computed everything, alone. He suffered a fever and turned blind in the right eye. He still had a happy life. He married, made more discoveries, won more prizes, and has immortalized his name. And he never gave up his incredible research pace, even if that meant going blind.